Okay, so we're going to start by introducing limits. So our goals, we're going to find limits. That is not what I wanted. Let me fix this. So our goal is going to be to find limits graphically, and I didn't want that either, and algebraically, and we're going to find limits of difference quotients. So homeworks are always going to be due on Tuesday. And let's start with our definitions here. So definition of a limit. So this is how we read it. This is the notation right here. And that notation is read as the limit of f of x as x approaches c is equal to L. And so here I put a note. The existence of a limit at c has nothing to do with the value of the function at c. In fact, c may not even be a domain in the domain of the function f. However, the function must be defined on both sides of c. So what that means, what I just read, is that in order for this to work, both of these need to be, the answer to both of these, needs to be the same L that we're talking about right here. So let me highlight it. So this L and this L and this L are the same. But before we start analyzing, let's just make sure we know how to read it. So here, this notation right here is the limit of f of x as x approaches c from the positive side. Which I usually call the right side, is equal to L. And the next one is going to be the limit of f of x as x approaches c from the negative side. Which is the left side, is equal to L. And we'll be practicing some pretty soon here. So we have a theorem. It says existence of a limit for a two-sided limit to exist. So what is a two-sided limit? So an example of a two-sided limit is this right here, because it doesn't ask you for the positive or the negative limit that is going to be listed right there and right there. So for a two-sided limit, it doesn't have the positive or negative, so it's implied that you need to have both of them. So what I highlighted in yellow is a two-sided limit. And let's fill in the blanks here. It says for a two-sided limit to exist, the limit from the left and the limit from the right must equal, and obviously be the same number. So this equal and the same number, let me highlight it here. Equal and the same number is again, oh, well, maybe I should be consistent here with the coloring. Where's my hot little pink there that I had recently? Is this L? So this equal to and the same number, again, is this L, that L, and that L. So one last time, in order for this limit to exist, these two have to end up being equal to the same number, which in this case we're using L to represent that number. And in order to see a limit graphically, we need to know our left from our right. If we don't, we're in a heap of trouble here. So I'm going to put it up here on the top of the notes. I'm going to be saying this quite a bit. So coming from the left, which is the negative side, is going this way, from in this direction, coming from the left. And the other one, coming from the right, is I'm going to literally coming from the right. I'm literally going to come from the right to whatever x value I'm coming from. I'm headed to. Okay, so let's see here. Instead of doing this theorem, let's look at these examples here. Okay, it says use the graph of the function shown to estimate the indicated limits and function values. So part A says it's the limit of the function. So here this graph represents a function. It passes the vertical line test from your previous math days. And we want to know what the limit of it is as x comes to 4 from the left-hand side, again, because of that negative. Now, one thing that I want to highlight here that's very important, and I'm going to write it down back here, is when we say the limit of f of x, I'm going to add it right here. In essence, we're looking for the y value at that particular point. So very important. Okay, so let's continue here. So we have this function, and at x equal to 4, coming from the negative side, which is the left side. So I'm going to put a point at x equal to 4. I'm interested in this spot, that point right there. And if I'm coming from the left, so I'm going to highlight this, and I'm taking this really slow. I'm going to use this color here. So for this limit, coming from the left means that I am interested. I'm going to put myself on the left part of the graph that's close to that x value of 4 on the graph, so which is technically this right here, and you can't really see that. Let me make it a little bit more darker. So this one right here is this one right here, and there's my arrow. So the question is, what is the y value headed towards from the left side of the graph approaching x equal to 4 on that graph? Well, the y value so I'm here headed on to the left part of the graph, and right there I'm going to stop because I want to get to x equal to 4 coming from the left. And if I come and read the y value, it's 4. It's 4. I'm going to use another highlighter, and I'm going to do part B. So part B is, yeah, that's good. I'm going to highlight this one. And so I'm just going to be on the, so this is saying the limit of the function as x approaches to 4, but coming from the right side. Okay, so I'm still interested at x equal to 4. So I'm still interested in this point right here. There's x equal to 4 as part of the graph. And I'm going to be coming from the right-hand side. So again, because of the positive symbol. So coming from the right-hand side, I put myself on the right part of the graph that's closest to that point that I just circled. And there's my arrow. And so what is the y value at x equal to 4 coming from the left? Well, the answer is 4. If you notice graphically, coming from the left and coming from the right, headed towards x equal to 4, I'm headed towards that same point. And because these two are the same, maybe I should do it in a different color. Because these two are the same answer, then the limit of the function f of x as x approaches to 4 is going to be 4. Part D says f of 4. Well, f of 4 from your previous math days is technically asking you what is the y value when x is 4. So I'm going to write that down just as a refresher. What's the y value when x is equal to 4? Well, if you notice the graph, it's an open circle. It's not a closed circle. So since it's an open circle, the answer is it doesn't exist. It doesn't exist. So the answer is D and E, does not exist, because at x, because actually I'm going to say the following. Because 4, 4 is an open circle. So it's kind of weird. You need to limits. Again, it's just where is the graph headed towards, whether that point exists or not as part of the graph. So in this particular problem, the limit is definitely 4 because again, those arrows are both headed at x equal to 4 anyway. They're both headed to a y value of 4. Even though for that function, f of 4 doesn't exist because it's an open circle. Now, part E asks, is it possible to define f of 4 so that the limit of the function f of x as x approaches to 4 is equal to f of 4? Yeah, the solution is easy. Change the closed circle to an open one. Change the open circle to a closed one. And for sure, f of 4 would be defined to equal to 4 because it wouldn't be an open circle. It would be now a closed circle and part of your actual answer. So let me write that down. Now the next problem, it'd be nice if you can try it on your own, but if this is new to you, it's up to you. You can pause and try it on your own and then check your answers. Okay, so next one, the limit of the function as x approaches 2 from the right hand side. So I'm going to try to use the same color coding here. Okay, so at x equal to 2, maybe I should highlight here. Here's the 2. That's not what I wanted. Sorry. I'll be doing that frequently. So here's 2 on the x-axis. And from the right-hand side, I need to put myself on the graph coming from the right-hand side. So here is on the right-hand side of x equal to 2 approaching it. There's my arrow. Okay, so coming from the right-hand side, from the positive side, what is the y value? Well, the y value is -3 right here. That's the y value of the point that I'm headed towards. This one right here. It's -3. Part B, the limit of the function f of x as x approaches 2, but from the negative side, which is the left side. So from the left side, at x equal to 2, this is the most closest left side. And this is the point that it is approaching. So what is the y value at that point? It is +3. So if for part C, the limit of the function f of x as x approaches to 2, well, because of these two not being equal, then the answer to this one is that it does not exist. So graphically, the limit is going to exist if you're having a particular x value, and you're coming from the left and you're coming from the right, and you're going to one specific point, then the limit's going to exist. In this one, if you're coming from the left and you're coming from the right, and you end up at two different points, which again are going to give you two different y values, then the limit at that particular x value that you're interested in, which in this problem is 2, it's not going to exist. Now, so f of 2. So f of 2 is asking you what is the y value when x is equal to 2. Well, at x equal to 2, we have two coordinates. We have 2, 3, and this is a closed circle. And we also have 2, -3, which is an open circle. So there's only one answer. Closed circles win. So the answer for f of 2 is again asking you the y value at x equal to 2. And since we have a closed circle, the answer is going to be 3. Now the next one here. Is it possible to define f of 2 so that the limit of f of x as x approaches to 2 is equal to f of 2? So in the previous problem, we said, yeah, just close the open circle and it'll work. Well, in this one, it's not going to work, because even if I close to -3, those arrows that are blue and I guess greenish, or excuse me, blue, I'm colorblind, green and reddish, they're not going to meet at the same point. So even if you close that open circle, it is not, the limit is not going to exist. Again, because the arrows, and I said one last time, but it's going to be quite a bit of times. The arrows coming from the left, coming from the right, need to meet at the same point for now, or later on they'll be headed in the same direction when we deal with infinities. But for now, they need to be meeting at the same point. So let me write down what I just said. So no. After closing to -3, the limit still won't exist. Since part A will still not equal to part B. Okay. These next problems are pretty much the same, except that now we don't have a graph. And here we have an equation. So find each limit if it exists. Let me come back up here. So let me go back and just make sure that I know that you know that I know that you know. So in order for a two-sided limit to exist, the left and the right have to be the same. Now, the next theorem says limits of polynomial, which are continuous functions from your previous math days, and rational functions, which are technically just fractions with equations in them. And the rational function, obviously, you can divide by 0. So the limit of f of x as x approaches to c, so I'm right here, is just f of c. So what does that mean? It really just means to substitute c wherever you see x to get your answer. So before we do this algebraically, I should have already set this up, sorry. Let's show you graphically here. Okay, come on technology, work with me. Okay, so I'm going to do this one right here. The limit of x minus 3 as x approaches to 5. So I'm going to graph x minus 3. So x minus 3, and here's the graph. And so if you see it as x approaches to 5, so as x approaches to 5, I wish I could put the point there. There's my point. And if I'm coming from the left and I'm coming from the right, hopefully you'll agree with me that the y value is in fact 2. Right there. And so if I do a quick sketch on my notes, and it doesn't want to do it, something like this, right here, we had 5, 2. And we could do the exact same thing that we just did on the previous page. At x equal to 2, which is the point, the x value that we're interested in, right here, I can do from the left and from the right. Hang tight. Okay, so I can do this now. So from the left and from the right, I'm headed towards that same point right here, which is 2. But really what the theorem says that we just did right now is that wherever I see an x in the function, I just put 5. Minus 3. And so really it's just going to be 5 minus 3, which is equal to 2. And this 2 right here is that 2 right there. It's the y value. So now instead of doing the graph, we're just going to substitute here. So this is going to be equal to, hang tight. So wherever I see an x, I'm going to leave a blank. Now I'm going to put 4 wherever I see an x. So I have 4 minus 2 is 2 over 4, which is a half, or 0.5. So not too bad, not too bad. So more practice on this. Given that the limit of the function f of x as x approaches to 1 is equal to -5, and the limit of g of x as x approaches to 1 is equal to 4, find the indicated limits. So here we're just going to substitute again. So this one's going to be, so if you notice, in order for this to happen, let me highlight this. All of them are approaching 1. So that's very important in these two problems. So now, it's just going to be g of x, which is 4. So this is going to be 4 minus 3 times f of x, which is -5. So this is going to be 4 minus 15, or 4 plus 15, minus a negative is a plus, and we get 19. You can do the next one on your own, or just go along here. So as x approaches to 1, so this is going to be the limit. So it's going to be the cube root of 2 times 1, because x is approaching 1, plus 2 times f of x, and f of x is -5. So this is going to be the cube root of 2 plus, technically -10, so it's going to be -8. And the cube root of -8 is -2. For this next problem, it says let f of x equal to, and it's a piecewise function, x divided by x plus 3 if x is less than 0, and x divided by x minus 3 if x is greater than 0. So for part A, it says find the limit of f of x as x approaches to -3. So for part A, we must use the first equation, since -3 is less than 0. And so let's see if we can just substitute it in. So it's going to be, instead of x over x plus 3, we're going to say, wherever we see an x, we're going to put -3. And we get -3 divided by 0, which, if you do it on your calculator, gives you an error. So this is does not exist. That's the answer. For part B, the limit of f of x as x approaches to 0. Well, in this case, this 0 happens to be a very important piece of the information of the piecewise function. So in order to do it algebraically without having to see the graph, since we have to analyze it coming from the left and coming from the right, we actually have to use both equations. Okay, so from analyzing from the right, so from the right is going to be x over x minus 3, and wherever we see a x, we're going to put 0, and 0 divided by -3 is 0. And so analyzing from the left, we're going to have to use x over x plus 3, because x is less than 0 is on the left hand side. And I'm going to get 0 over 0 plus 3 is 0 over 3, which is 0. So these two are the same. And my three little dots here mean therefore. So therefore, the limit of the function as x approaches to 0 is going to be 0. And the last one, so the limit of the function as x approaches to 3, we must use, the second equation, since 3 is greater than 0. So it's going to be x over x minus 3. And we're going to put 3 over 3 minus 3, which is 3 over 0, which is another does not exist. Now let's verify these answers by graphing. So let's practice here. And the reason being is that this is going to be on the final for sure. So heads up. So we need to make a table. So we have two equations, x and f of x. And the first f of x is going to be x over x plus 3. And this is going to be for x values less than 0. Well, I'm going to start at 0, but I'm going to know that it's an open circle. And I'm going to put 0 over 0 plus 3, which is 0 over 3, which is 0. So at 0, 0, I have an open circle. I'll probably zoom this in a little bit more. And negative 1 would be negative 1 over negative 1 plus 3, which is negative 1 over 2, which is just negative a half. So at negative 1, I get negative a half. So I'm going to do negative 2, negative 3, negative 4, negative 5, and negative 6. If you do these on your calculator in the interest of time, for negative 2, you're going to get negative 2 over negative 2 plus 3, which is just going to give you negative 2. At negative 3, I said it in the interest of time, but let's just do these. So it'll be negative 3 over negative 3 plus 3, which is negative 3 over 0. So this one, we know from our previous math classes that technically we can't divide by 0. And we can't factor the numerator and the denominator. So now we know that here it does not exist and we had a vertical asymptote. At negative 3. So it's not part of the graph, so let's make it a different color. At negative 4, it's going to be negative 4 over negative 4 plus 3. So at negative 4, it's going to be negative 4 over negative 1, which is just 4. Hang tight. At negative 5 over negative 5 plus 3 is negative 5 over negative 2, which is 2.5. And at negative 6, we're going to get negative 6 over negative 6 plus 3, which is negative 6 over negative 3, which is positive 2. And we should also know from our previous math days that since these two are understood powers of 1, we have a horizontal asymptote at y equal to 1. That's this right here. So far we know this about our graph. This is going to behave this way. This so far is behaving this way. Okay, so for the second equation, we have, let me put it here. We're going to have x and we're going to have f of x. And it's going to be x over x minus 3 if x is greater than 0. Okay, so I'm going to zoom in over here. So I'm going to do 0, and I already know it's going to be an open circle because it doesn't have the equal to sign. So 0 over 0 minus 3 is just going to be 0 over negative 3, which is 0. For 1, it's going to be 1 over 1 minus 3, which is 1 over negative 2, which is negative 0.5. And that one is a new point. So for 1, I get negative 0.5 right here. 2, 3, 4, 5, and 6. So for 2, I'm going to get 2 over 2 minus 3, which is going to be negative 2. For 3, I'm going to get 3 over 3 minus 3 is 3 over 0, which is does not exist. And again, we can't divide by 0. That should have given us a heads up that we have an error there at 3. And we can't simplify it with the numerator, so we know we have a vertical asymptote as well. So let's write that one down. Let's put it right here. And then at 4, we're going to have 4 over 4 minus 3. So 4 over 1, which is 4. At 5, it'll be 5. 5 minus 3 is 5 over 2, which is 2.5. And then for 6, it'll be 6 over 6 minus 3, which is 6 minus over 3, which is 2. And so this is our graph. Now it does take quite a bit of time, but let's verify our answers here. And again, most of the time, the algebra is much quicker. So now we have this as part of our graph. So let's see. The limit, so I'm going to do part A here. So the limit of the function f of x as x approaches to negative 3. So I want to use the same colors that I did before in the highlighting and see if I can find them. Nope, doesn't want to let me. It was a little bit darker. Okay, so at negative 3, here's negative 3 on the number line, on the x-axis. So coming from the left, and I wish I could get that same color, coming from the left, I'm going to be anal about it. I'm going to try it. So coming from the left, at x equal to negative 3, I'm on this part of the graph. I'm on this part of the graph. And so that's going just forever up. And I also need to analyze the right part of the graph. So the right part of the graph coming, the closest right part of the graph, excuse me, at x equal to negative 3 is this part right here, and it's going this way. So if you notice, they're not merging at one point, they're not headed in the same direction. So that's why the answer to part A graphically is it does not exist. So we just verified this answer right here. Part B, so at 0, coming from the right and coming from the left. So for part B, I'm gonna use, darn, now it's gonna get interesting here. Well, I can erase, maybe I can't erase, but let's see. Okay, so for part B, so it was right, I'm just erasing so that we don't get confused with all the arrows that I'm gonna be drawing. So for part B, analyzing from the left and from the right, we can see, so I'm going to, from the left, I'm headed here, and coming from the right, I'm headed here. So we're merging at the same point. And again, for limits, we're looking for the y value of that point. And the y value of the point is in fact 0. So that's why we got that one. But again, the algebra is definitely much quicker. Okay, and for part C, I'm going to undo this again so that we can see for part C. So it says the limit of f of x as x approaches to 3. So coming from the left, so here is, I always do that. So here's x equal to 3 right here on the x-axis. And I want to analyze coming from the left. So I'm going to put myself on the left part of that graph that's closest to 3 and see where the graph is headed. Well, that's where it's headed. And coming from the right, so the right part of the graph that is closest to 3 is this right here. And again, they're headed in different directions. So that's why this answer is does not exist. For this next problem, it says let f of x equal to x squared plus x minus 6 all over x plus 3. So we might say, okay, let's do part A, limit f of x as x approaches to negative 3. Let's just substitute negative 3 in. So let's do it. Negative 3 squared plus a negative 3 minus a 6 will give me 0 on the numerator. And then negative 3 plus 3 gives me a 0 in the denominator. So this is what's called an indeterminate form. So we're kind of sad because we got some work to do. And so let's go back up here to the first page of the notes here, and let's continue with our definitions here. So I'm right here. If the limit of f of x is equal to 0 as x approaches to c, and the limit of g of x as x approaches to z is also 0, and you're dividing f of x, which is the 0, the limit of g of x, which is 0 as well, is said to be an indeterminate form. It's also called a 0 divided by 0 form. So here's what I already put in the previous page. It says when you get a 0 divided by 0, you're kind of sad. There's extra work. And the key word here is factoring, if it's possible. So if it is factorable, simplify and substitute your x value to get your answer. And unfortunately, it's still possible to get 0 divided by 0, even again. Okay, so let's go with this problem right here. All right, so we need to factor. So if we're going to factor, here we go. So I'm going to put it here. I have x squared plus x minus 6 all over x plus 3. So the top part is factorable into x times x gives me x squared. To get a minus 6 and to add up to an understood 1 in the middle, it's going to be a plus 3 and a minus 2. And I'll leave it up to you to factor. And so if you notice here on this one, maybe we don't, but it's all highlighted. This and this are the exact same factor in the numerator and the denominator. So we do. So now we're going to simplify it. And so technically, this x plus 3 and this x plus 3 in the denominator simplify to 1. And then I'm just left with x minus 2. And this is the simplified form. And once you have the simplified form, that's what you're going to use to find this limit here. So I'm going to put the simplified form for x minus 2 is going to be negative 3. And again, where did I get the negative 3? Hang tight. Sorry. This negative 3 is that negative 3. So negative 3 minus 2, my answer to this limit is negative 5. The limit of f of x as x approaches to 0, 0 squared plus 0 minus 6 is negative 6. And 0 plus 3 is 3. And negative 6 divided by 3 is negative 2. That's the answer to that one. The limit of the f of x as x approaches to 2. So I'm just going to put 2 squared plus 2 minus 4 over 2 plus 3. So 4 plus 4 is 6 minus 4 is 2. Excuse me. Over 5. I'm sorry, 2 squared is 4 plus 2 is 2, but here I should have put a... Oh, I took out the $1 million eraser. Sorry about this. Just try again. So it's going to be 2 squared plus 2 minus 6 over 2 plus 3. So 2 squared is 4. 4 plus 2 is 6, and 6 minus 6 is 0 on the numerator. And 2 plus 3 is 5. So this is going to be 0. So when we have this indeterminate form, we have a little bit more work to do. And you might just want to confirm your work when you're done with your graphing utility. So I already went and graphed it here. Let me make sure that I did it right. So we have x squared plus x minus 6. I put in parentheses to make sure all of it was divided by x plus 3. And if we notice, we have a line. It looks like a line. But we said that we have a problem at negative 3. But it doesn't look like we have a vertical asymptote. So if we don't have a vertical asymptote, then that means that at negative 3, we have an open circle. And there it is. Okay. And we should probably have other points that we can use. So I'm going to go ahead and graph it here. So I have 0, negative 2. At negative 3, what was it? Negative 3, 5. Negative 3, negative 5. I have an open circle. And that's enough for me to get a line here. Okay. So now that I have this one, so at negative 3, here's negative 5. And so coming from the left, and coming from the right, this is for problem A, I definitely am reaching the y value of negative 5. For 0, So coming from the left for 0 and coming from the right at x equal to 0, the y value that I'm reaching is definitely -2. So that's for part B. And for part C, the limit of the function as x approaches to 2. So for 2, so my line's a little bit off. I should probably fix this. Make sure I don't have the $1 million eraser. Okay, so at x equal to 2, let me put the 2 right here. Here's 2. So coming from the left and coming from the right, the y value that they meet at is definitely 0. And there's your answer right there. Okay. Moving right along. Trying to zoom out here. So the next ones we're not going to graph is the limit expression 0 divided by 0 indeterminate form. Find the limit or explain why the limit does not exist. So you can graph them if you so desire. So this is going to be, the first thing again, I'm going to substitute it in. So 9 squared plus 5 times 9 minus 36. If you do that in your calculator, you get 0 for the numerator. And then 9 minus 9 is 0. So yes, it's indeterminate. So we got some work to do. So coming over here, x squared minus 5x minus 36. So x times x will give me the x squared. Two numbers that multiply to give you -36 and add up to a minus 5x is going to be minus 9 and plus 4. And again, these our two factors are the same in the numerator and the denominator. So I'm left with x plus 4. And so 9 plus 4 is equal to 13. And again, you can graph it, and hopefully coming from the left and coming from the right at x equal to 9, the y value of the graph is 13. Next one. So we're going to substitute it in. So 10 squared minus 15 times 10 plus 50 gives us 0. And then we have 10 minus 10 squared also gives us 0. So yes, it's indeterminate. So we have to factor. So again, I'm going to put it here, factor, and I'm going to put here, factor. So we need to factor these equations out. So this numerator is going to be x times x to get a plus 50, a 10 and a 5, so minus 10 and a minus 5. And then x minus 10 quantity squared is x minus 10 times x minus 10. So again, these two are the same. And so I'm left with x minus 5 over x minus 10. And I'm interested in x equal to 10. So this is going to be 10 over 5. 10 over 10 is 5 over 0. And therefore, my answer does not exist. My number on the top is not a 0, so I'm happy about that. I can't divide by 0, that means it's D and E. All right. Last one, x plus 3 over x minus 3 as x approaches -3. So this is going to be -3 plus 3 over -3 minus 3. This is 0 over -6, which the answer is just 0. So this one is not indeterminate. And we were able to get an answer. Okay, little word problem here. A state charges polluters an annual fee of $20 per ton for each ton of pollutant emitted into the atmosphere, up to a maximum of 4,000 tons. After that, the fee is fixed at $80,000. So write a piecewise definition of the fees f of x. So f of x is going to be, it's $20 per ton. And so x is the number of tons of pollutant in a year. So this is going to be 20x if x is, so it's up to a maximum of 4,000. So it could be less than or equal to 4,000. And in the real world, it has to be greater than 0. Okay. After that, the fee is fixed at 80,000. So it's going to be 80,000 if x is greater than 4,000. So there's the piecewise function. And what is the limit of f of x as x approaches 4,000 tons? Okay, so we need to find the limit of f of x as x approaches 4,000. Okay, since 4,000 is this threshold between these two pieces of this piecewise function, we need to use both equations. So here I go. So I'm going to do the limit of f of x as x approaches to 4,000 from the left side. And that's going to be, I need to use 20x. So that's just going to be 20 times 4,000. Which is 80,000. And then I also need to do the limit of f of x as x approaches to 4,000 from the positive side. Or from the positive side, it's just saying it's 80,000. So just to make sure that you know that I know that you know where I'm getting this. This one is this one. And this, I needed to use 20x from coming from the left side. Now, since these two are the same, then we can conclude that the limit of f of x as x approaches to 4,000 is equal to 80,000. Now, as it approaches 8,000 tons, so the limit of f of x as x approaches to 8,000, we only use the second piece. Therefore, the limit of f of x as x approaches to 8,000 is going to be 80,000. And it's that same green one that we have in the piecewise.